What if some of the greatest discoveries in astronomy only happened because something went terribly wrong first? In space science, mistakes don't just slow us down. Sometimes they completely change what we know about the universe. A miscalibrated telescope, a failed mission, a wrong assumption about a planet. Each one has helped uncover a deeper truth. Today, we're looking at astronomy's biggest mistakes, the space disasters that didn't just make headlines, but actually taught us how to explore the cosmos better. Because in astronomy, failure is often the first step toward discovery. Let's start with one of the most famous examples, the Hubble Space Telescope. When Hubble launched in 1990, scientists expected razor-sharp images of distant galaxies, nebulae, and stars. Instead, the first images came back blurry. The reason was almost absurd. A tiny flaw in the mirror, just a few microns off, was enough to ruin the telescope's vision. But that disaster taught a huge lesson. In precision astronomy, microscopic errors become massive problems. The fix: astronauts later installed corrective optics, kind of like glasses for a space telescope. And the result was incredible. Hubble went on to transform astronomy, showing us the age of the universe, the birth of stars, and galaxies billions of light years away. Why this matters practically? It showed engineers that testing systems in extreme detail is non-negotiable. Today, telescopes and satellites are checked with obsessive precision, because even the smallest defect can affect years of research. Now let's go to Mars. In 1999, NASA lost the Mars Climate Orbiter because two engineering teams used different measurement systems, one in metric, one in imperial. The spacecraft went too low, hit the atmosphere, and was lost. It sounds simple, almost embarrassing, but the lesson was enormous. Space exploration depends on absolute consistency. One unit mismatch can destroy a mission worth hundreds of millions of dollars. That failure changed how agencies handle verification, communication, and software validation. And the useful takeaway goes beyond space. In any complex project, whether it's coding, engineering, or medicine, small communication errors can lead to catastrophic outcomes. Astronomy also has failures of interpretation, not just hardware. For a long time, scientists thought the universe might be slowing down after the Big Bang. Then observations of distant supernova suggested something shocking. The expansion of the universe is actually accelerating. That result didn't come from a disaster in the usual sense, but it did come from the possibility that earlier assumptions were wrong. And it opened the door to one of the biggest mysteries in science: dark energy. That's useful because it reminds us that sometimes the mistake isn't in the data, it's in the story we tell about the data. These space disasters matter because they forced astronomy to become more careful, more accurate, and more creative. They improved telescope design, mission planning, software testing, cross-team communication, and our ability to question assumptions. In other words, every mistake made the next discovery more reliable. So when you hear about a space mission gone wrong, don't just think of it as a failure. Think of it as a turning point. Because in astronomy, the universe doesn't just reveal itself through success. Sometimes, it teaches us most clearly through disaster. And that's what makes space science so fascinating. Every mistake can become a map to something bigger. Astronomy's biggest mistakes, the space disasters that taught us everything, is just one small part of space disasters and hard lessons. If you're interested, our full free space disasters and hard lessons course is linked in the description.